moved to Silicon Valley and got to work on pretty cool projects like the Tesla Model 3 launch. So I was liaisoning between these development teams and the manufacturer. And in development, especially, it's like I needed my parts yesterday, so it needs to move very quickly. So any inefficiency creates delays, upset customers, delayed product launches. It's a pretty big deal in engineering and manufacturing. So it was at that moment working in the factory, realized like how much chaos there can be.
Welcome back to the Advisor AI Solutions Podcast, the show where we sit down with builders, operators, and innovators shaping the future of sustainable infrastructure, manufacturing, as well as technology. I'm your host, Jordan Salvador, and on this show, we are going to go beyond buzzwords. We are going to unpack how real companies are using data, automation, and AI to scale without chaos, reduce risk, and make better decisions in the real world. Today, I'm joined by Zakary Smith, co founder and CEO of Sensflo. Zach, for listeners who are hearing about Sensflo for the first time, mind giving us the quick overview on what you guys build and who it's for?
Yeah, for sure. Thanks for having me today, Jordan. I'm really looking forward to the conversation. At Sensflo, we're a machine monitoring and AI software company. So we work with industrial manufacturing companies to help them process data in real time on the factory floor, in fact, making better decisions and optimizing their workflows to ensure, you know, equipment utilization, production efficiency, and quality all head in the right direction.
I love it. It's true. Like, you can't really fix what you can't see, right? You can't automate what you can't see. So, bringing you guys in essentially helps aid in that process, right?
Yeah, exactly. I think that's really the starting point, depending where a company is on their digital transformation journey. So, um, seeing what's happening, both historically, in real time, and then we really like to do predictions in the future. But the starting point is like what happened yesterday, what's happened in the last hour. That adds a lot of value to that decision making process.
Absolutely. It's all about relevancy, right? Okay, Zach. So before SenseFlow, what really pulled you into this world? Was it technology first, or did you notice inefficiencies in real operations that made you think, hey, there's a better way to do this?
A little bit of both. So I studied mechanical engineering and tech entrepreneurship. So I always knew I wanted to work in the realm of manufacturing, engineering, product, but sit between the technical and the business side of things. I worked at an aerospace company right out of college doing advanced concepts engineering. So I got my hands on design, prototyping, and manufacturing there. And then I was fortunate after that, I moved to Silicon Valley and got to work on pretty cool projects like the Tesla Model 3 launch, the Roadster steering wheel, some projects with like Google Loon. So I was liaisoning between these development teams and the manufacturer. And in development especially, it's like I needed my parts yesterday, so it needs to move very quickly. So any bits of inefficiency creates delays, upset customers, delayed product launches. It's a pretty big deal in engineering and manufacturing, especially on the consumer side, where a product is released and they're already like basically producing the next release. So it was at that moment working in the factory, realized like how much chaos there can be. And you know, I always had the entrepreneurial itch and, following working for about 6 years, moving back and forth, between Silicon Valley and Asia and then across the world with different engineering firms, had an opportunity and made the jump to start my own business alongside my co-founder, Dr. Yen Cheng.
Awesome. Well, it sounds like you have quite an impressive background with some really cool projects. But that's some great insight to be able to take all that together and be able to identify that there are those gaps, and you guys have the intuition to be able to deliver something to that that fills it.
Appreciate that. It's interesting because I think the problem always existed. And we had our eyes set on a specific technology suite, but AI is advancing so quickly. I don't think there's a person on the planet that denies that. And I feel fortunate with my co-founder to his doctorate is in precision controls, robotics, and AI. So for quite some years now, since we started the business, he's been really trying to push us and progress us to focus on the AI development side of things. What's interesting there is we've always had some core models, but we held back on pushing forward with them too aggressively because in an industrial environment, as we started at the beginning of the conversation, like the data is so important and um, you need that data foundation for the AI to be able to provide value. So I feel like we're just getting to that point now where you have like that really good like digital um transformation data layer foundationally, and now you could couple that with that next generation of AI.
Right, no, that definitely tracks. It's all about data, be able to enter good data to be able to create wonderful results, right? So, okay, so Zach, a lot of leaders say they want AI, but very few are actually ready for it. So, what needs to be in place before the AI actually works in a factory or production environment, outside of just data?
hmm Yeah, so I think different businesses are at different stages of that journey. So like on one end you have companies that are literally producing, working with both equipment and manual labor, and maybe some combination working together. But like pen and paper, like I'm literally manually taking down critical data points, right? Like when I started the job, what the job is, how many parts are being produced. That's on one end. And on the other end is you have companies with like sophisticated ERPs, enterprise resource planning, MESs, manufacturing execution systems, which is really defining like the start and stop of an operation, what's being produced, how many are being produced digitally. And then you have your quoting, your finance, right? So you have all of these systems that work traditionally independently, but have various data sources that need to work in and amongst themselves. And then on top of that, there's new ways to collect data. And I think that's kind of our perspective is a lot of these like manual data entry points can be they're not really value add with regard to the businesses themselves, right? They're necessities to understand what's going on, but they don't inherently add value to the process. But without it, you don't know what the heck is going on. So that additional point of like good data would be stuff that would be historically manually generated, whether it's pen and paper or digitally, and then automating that data collection. And the nice thing about that is there's not a data delay, and then the integrity of the data um, is much more accurate, and then it goes much deeper too. Like, we're talking bits and bytes, not processed like part counts at that point.
Right. Oh, that's awesome. So you guys are basically speeding the processes up while enriching the data and improving the quality, right? So that you're able to trust that data even more so. Is that correct?
Yeah, definitely. So the process of like the data foundation would be that we choose a technology stack that's going to be not cost prohibitive, but get the job done. You could go crazy with what I would call the hardware selection part. My perspective is that the hardware on the data collection side for gathering is commoditizing. So cost is going down, and you want to collect just enough data at a frequency that gives you accuracy on what's happening. So it's very easy to over or under spec the hardware to collect the data that you would need. Once that's done properly, it's typically a very quick process to do the installation, the configuration, and then we always like to do a sign off with the customer, right? Like it's very easy to just to start using it, but unless you validate that it's correct, it could lead to a lot of problems downstream. There could be subtle things, nuances within their operation, the machine, the process that get missed, and that would lead to ultimately the same issue that you started with, which would be delayed or inaccurate data. So there's a way to really get it crisp so you get it done right the first time and then you don't have to go back and fix it later.
Okay, cool. No, I really like what you guys are doing there. Do you mind kind of walking us through maybe like a real example of how you guys' monitoring systems are actually in play?
Yeah, I'd be happy to. So we're industry agnostic, but I'll use a plastic injection molding process as an example. It's an area that I think we play nice in. So the first thing is there's typically three ways to connect to the data on the equipment, depending on the vintage, make and model of the machine, make and model of the controller. So we go in, we look at the detailed information of the machine, and then we help factories understand like what's even possible. Like how deep can you go on the data? How do you connect? And we architect that for the entire facility. So on a per machine basis, we let them know what data you could get out of your operation. There's a I actually have this right here on my desk, but there's a well, we have these little tags, and with the injection molding process, you have a machine, but you have a mold, and the mold is what's creating the part. And we could wirelessly track that information through the technology. So upon a one-time configuration where you used to have to like, okay, what mold am I running, and then how many cycles am I producing based on the number of cycles and the mold and the cavitation in the mold. Let's say there's you did 1,000 cycles and you have four cavities in that mold, so you'd have 4,000 parts right in an hour because of that. So what we do is we eliminate completely that manual process of defining what parts being produced at what rate, how many parts you're getting, and then the efficiency of it. So once the technology's in, you're getting real-time information on what's running, at what rate. If the machine goes idle or you fall below your efficiency, you're being notified in real time. So we're talking about text message, WhatsApp alerts, email, Teams, Slack's message. Again, we really are cognizant about the fact that no two factories are the same. That means their equipment's not the same, their people are not the same, the technology stack they use on the software is not the same. We don't want to cram people into a use case that only works if you do it this way. We want to say, hey, what is your stack in those areas? So, like hardware, people, software, and how do we adapt the technology and configure the technology so it's just going to work? We don't want you changing your process. We want this to be like think of it like hiring an amazing employee that comes in and adds value to your business. We want this to come in and add value without you having to change what you're already doing, and then you could focus in other areas. So that would be a use case. I could answer more questions if you want. There's a lot more to talk about in that area, but that's kind of how we come in, how we architect it, deploy it, and some of the immediate value companies can get upon installation.
No, that's absolutely, wonderful and fascinating really how you guys are able to take these factories to the next level, right? Once you guys have, those certain foundations in place and then have AI really start to create real leverage for them with a bespoke system that you guys have created for them.
Yeah, I mean, the part about the AI is really interesting, right? Because now we have like a data foundation. So there's certain things like, chatting with your factory, identifying areas that are creating inefficiency. Um, Up until about, I would say at scale, maybe 6 months ago, we were primarily deploying the what is going on. What are you running? Um, Also the when. When are things happening? But the why is really the next the turning point, and I think where extreme value is added. So it's like not only do we know what's happening, but we know why. And that's the reasoning part with the AI that adds a lot of value that we're focused on now is like helping customers understand why things are happening so they could fix them. The engineers and the management still needs to go in and a lot of times fix the problem. But if you give them, when it happened, what was going on, and why, it's a
Yeah.
pretty good jumping off point to fix the problem.
That seems super powerful. But you mentioned something, and maybe you can unpack it a little bit, but are you said you can chat or talk to the factory. What did you exactly mean by that?
Yeah, so I think people are pretty familiar with like Gemini, ChatGPT, that type of LLM chat functionality. So What we do is, going back to the data, like once we configure your data sources, and that could be the machine data, the ERP, anything, we provide a chat functionality with the cloud-based platform. So you could be a manager or like a plant manager on the road or out. We have one customer, he likes to spend the month of December in Cancun, which is pretty cool. All right. So you might have questions that need to get answered. Instead of like calling someone up or running a manual report, you just ask and prompt for that information. The AI goes into the database, reviews your personalized context and information, and comes back with answers for you.
Wow, but that must save so much time. Cool. Um, okay, so when we're talking about efficiencies and, saving time and effort and energy, where are you guys seeing the biggest efficiency gains today? And, like, are you able to put a number on that?
Yeah, for sure. So, a few years ago, we were seeing at least 20% utilization improvement within the first 90 days of deploying. So that means, if machine's running 10 hours a day, it's now running 12 hours a day. That's been shortened to the first 30 days of deploying the technology, which is really cool. So that's the first part is like getting your equipment to run more frequently, more hours out of the day. Just because they're running more often doesn't mean you're having more output. So there's the next part of it is on the efficiency side, understanding what the throughput is during that runtime. Um, similarly, that could be an additional 10 to 20% improvement pretty quickly. And then the next part of it is really there's a lot of automation being done with like the reading and writing between systems. So historically, like a purchase order might come in and somebody might need to like manually take the information off the PDF and write it into their ERP. Now the PDF hits an inbox. We grab the PO and then we extract the information and write that into the ERP. Um, those are additional efficiencies and gains, not necessarily directly attributed to um, the machines itself, but the processes within the organization. So we're doing a lot of that with regard to like supplier portals and ERPs. We talked to someone today, like somebody's spending maybe about a day a week on that process within one of many portals. So there's definitely, I think, the human side of it as well, which is an important topic for sure because like the technology, we believe in Industry 5.0, which is the human machine portion of this. Um, so I think we need to be really cognizant about where the technology is good and could enhance. There are some places of replacement. That is the reality of the technology. And I think it's important to recognize where humans are best fit to really enable them and use those resources in areas that are gonna like have longevity and value.
Right, right. So it sounds like you guys, are able to integrate on, multiple facets, right? When it comes to equipment, I think downtime prevention, right? Being able to run longer, be able to run better, is a huge asset to any process. But then also being able to optimize the skilled and human labor side of things as well is also a massive win.
Yeah, definitely. So on the maintenance side, there's definitely techniques like I think a car is a good example of this. Like traditionally, it's like every 10,000 miles now with like synthetic, you get your oil change. And obviously, we have electric vehicles, which are a lot lower maintenance, but still, a majority are ICE vehicles. Um, with regard to that, it's important to recognize that m- you have the maintenance where it's like I've ran my machine for a certain amount of hours and should maintain it. That's something that actually is very difficult to do because people don't typically have that data. That would be on the preventative side, but on the predictive side, there's indicators of specific faults, alarms, and messages that are happening at the control layer that could allude to specific maintenance requirements. So that's a really good area of enabling the maintenance team to avoid catastrophic breakdown and provide, you know, maintenance at the right time, I would say, with regard to the human side to it. So it's really trying to be an enabler or alerting someone there too to let them know it's, time to do a maintenance with that before catastrophic breakdown, which ends up being a lot more costly to a business than if they just maintained it. Yeah.
No, that's very strong insight. Okay, so Zach, just to kind of bring it into the construction side of things here,
Mhm.
how does Sensflo translate into, say, prefab or modular manufacturing or any maybe construction adjacent environments?
Yeah, we touch that in a lot of ways. So the first would be on the building material side of things. A lot of the factories we work with are the precursor to the materials that end up at construction sites, whether that be like actually prefabbing or raw material. So it could be rebar, it could be I beams, a lot of metal material we work with in that space, as well as polymer building materials, right? So we're very involved, upstream in the vertical integration, the construction space. We do a little bit of like vehicle telemetry that would be used on in construction sites, but really the area we focus in is on like the materials prep side of construction. Um, a lot of the factories you work with though might manufacture as well, not just the materials, but manufacture the equipment that's then used on the construction site as well. So.
Okay, cool. But well, I guess when it comes to construction, it's really manufacturing just with slower feedback loops, right?
It there's some really cool construction solutions I've seen. I mean, I think the labor calculation on construction sites is a big one, but I mean, one interesting, I guess, concept, and you probably could speak more intelligently to this than I could, but like a lot of construction projects still rent the equipment. Right? So they would want to maximize the utilization of that equipment or like rent it for as little as possible. Like the longer you rent it, the more you're paying. So I think there's a unique equation there with like the rental time, the usage of the equipment, getting it in and out as quickly as possible to, maximize like and optimize like scheduling and costs for the project. Like that's a really, I think, a directly transferable um like cost process, scheduling process between direct manufacturing and construction, which is just like you said, manufacturing on site at the end of the day. It really is.
Right. No, exactly. All right. So, Zach, you work with real machines, real people, real constraints on the daily, right? So, what are you seeing across machining, uh, injection modeling, and say production environments that surprised you the most?
Yeah, it's a great question. I think that even when like new machines and processes come in, it's unless you rip and replace an entire process, like your things are not moving per se as like robotic and automated as people might think. I think it's a slower process because of the level of CapEx investment in some of these legacy equipments. A lot of the equipments we're talking about are high 5 figures, high 6 figures, even 7 figures, right? So you don't spend that money on a piece of equipment and just replace it, and they're very capable. The other thing is I think it's a really, important challenge that we have, especially here in North America and even moving to Central and like South America, is the labor constraint. I think, um, we hear it time and time again, like the labor portion is a big constraint in the manufacturing process. And I think that gets solved through training, education. Um, I think, this work is the work that creates like the comforts, the lifestyles that people want to have, that from everything from education to housing, right? Safety. So it's so important that we take seriously the necessity of the people that make these processes and you know stable and go.
Right. No, that makes it feel like the work is that much more meaningful, right? I think that's very powerful statement there. But okay, so when it comes to having success with AI and looking at different teams that you've maybe worked with and alongside, what do you think separates them from a team that has success with AI or a team that struggles?
I think that the number one thing is the culture element, right? I think there's people with growth mindset and people not with growth mindset. I know it's a oversimplification, but we've seen instances where people lean in and they're excited and they want to learn and they see the potential. You know, we have one this woman, she's a plant manager, she's amazing. And like when we showed her the technology, her eyes lit up and she's like, "You mean I don't have to spend 2 hours a day doing that?" Because she understood that her value and that she could spend her time doing other things. There's also the other side of it where it's like, you're gonna take my like, you're gonna spend like, I'm supposed to spend 2 hours doing that, and it could feel threatening. And I think the reality is whether people like it or not, like, this technology is coming and it, it's here to help, and it's an opportunity to find things that people could really lean into. So that mindset is, really important with organizations, and we just try to explain that it's like the business's goal is to be successful with, like, their product category ultimately, and we're here to help with that, and if we could help with that, it helps everybody from the top down, and, but there's a culture shift for sure.
Absolutely. No, managing change is always going to be pretty difficult, right? The technology is easy, but once it's there, it really can't emphasize what you're already excellent at. Okay, so let's zoom out a bit for a moment, Zach. Um, you kind of mentioned you guys like talking about the future, but where do you see AI in manufacturing heading over to say the next few years? Which is always a difficult question to ask anyone, but
Yeah, I think there's gonna be, like, talk about it in stages, so I think we've been really good at the what's happening, when it's happening. We're now starting to perfect the why. Why is what's happening, which helps solve it. And then the next part is the feedback loop. So we know why it's happening. How do we fix it?
mhm,
We're starting to work on that now in large part. Like that's I call it like a V3 to the system. We've now deployed our V2. We'll be moving to a V3 over the next several years. But this is we're talking about doing real-time data processing across multiple systems and then using that to influence the controls on the equipment or at least make sure somebody on the human side makes the change uh you know manually or semi-automated. So that would be kind of my thoughts. I also have thoughts on like the robotic side. I think I'm watching very closely like things like Optimus, and there's a chance in the next 6 to 12 months that we see what happened on the compute side with AI happen in the physical world. And if that happens, it's gonna be really interesting, really interesting.
what do you mean by the compute side of things?
Yeah, so when I say the compute side of things, like, I'm talking about, like, the non-physical world, kind of like the thinking area. Um, you ask a question, you get answers with reasoning back. Um, so that's kind of computed at the software layer. It's happening on the back end on hardware, but that hardware is non-physical in the sense that there's no moving parts. So applied AI in the physical world, like something as simple as, undoing and screwing on a bottle cap is like that's being done by humanoid robots today,
Mhm.
right? It might seem simple, but if you do that with like real-time reasoning, could we send an alert from the machine to the robot, and can the robot go back to the machine and make a change?
Right. How to improve it.
Yeah.
That's cool. Okay, yeah, so really then data is no longer really a byproduct, it really becomes the infrastructure, right, to become stay competitive.
Yeah, I would agree with that. Yeah, it's
Okay.
I was, I sent something to someone the other day. It was just like an infographic of like Lego blocks, and it talks about Legos in the terms of data, and it's like a 5-stage process. Like the data is just a bunch of Lego blocks like mixed together and not doing anything, but you could go as far as like making a story with it, right? You could organize them by color, by shape, like right, and then you could actually like there's stages to it. So as you said, it's infrastructure. The data is infrastructure.
100%. Okay. So, all right. So it's been a great conversation, Zach. Really appreciate you sitting down with us. But if someone only remembers one idea from today's conversation, what should it be?
Yeah, I mean, we didn't talk about it too much, but I would say the thing to take away would be like, do it for a reason, right? Like, it's we're not developing this for the sake of developing it. I think between manufacturing, construction, like, there's a reason we're doing these things. So I think in the process of improving and becoming more efficient, it should really tie back to the reason and the purpose that we're doing it in the first place, and just being conscious about that is really important.
No, I couldn't agree more, right? It only works when it reflects in reality and it has meaning behind it. All right, Zach, for people who want to learn more about SenseFlow or maybe connect with you directly, where's the best place to find you guys?
Yeah, thanks for asking. So our website's sensflow.ai, SENSFLO.ai. It's a great way to see, more about our company, the product, specific customer use cases that have been shared. And then if you want to connect with me, LinkedIn's the best place. Just Zakary Smith, Zakary Smith. Check it with the Sensflo, should pop right up. So
Wicked. I'll definitely post these in those contacts in the notes. But Zach, thanks for joining us and sharing such a grounded, a real world perspective on what it actually takes to make AI work in manufacturing and processes. And to everyone listening, if you found value in this conversation, make sure to subscribe, share the episode, and follow along for more conversations with leaders building the future of sustainable infrastructure, just like Zach. And until next time, remember, automate the ordinary and scale the extraordinary. Peace.